The secret on these is to just take it one piece at a time. In other words, let's start out working on the numerator. Now, they might have actually taught you a different technique in class, because I have another student going there and they kind of taught him a different technique. Myself, I don't know. I want to go ahead and subtract these two fractions. It's the way I do it.
Yeah.
They might have taught you a technique in class to find a least common denominator that you can multiply every denominator by in one step. That would be another way to do it. In other words, I would look at the denominator down here and up here, and can I multiply everything by 3x times x plus 2? Yes, I could, and that would get rid of everything. But I think it's easier to see if you work on it one thing at a time. How do I subtract these two fractions?
You have to find the least common denominator.
Which is?
3x and parentheses x plus 2.
What goes upper left?
Just x plus 2.
Upper right.
12x.
Simplify.
Which be... wait, what do you mean by simplify? Just cross out?
Well, no. In other words, we can now subtract these fractions because they have the same denominator. So now operate on the numerator.
Oh, okay. So it's just negative 11x plus 2.
All over this. So that is our new numerator in place of that. Okay? Now, let's work with the denominator. Let's do the same thing. What's the common denominator?
X parentheses x plus 2.
Goes here.
X squared.
Here.
Is it just x plus 2?
Simplify.
X squared plus x plus 2.
Can that be factored?
No.
Correct. Okay. So that is our new denominator. Okay. So to divide that by that, what am I going to do?
Don't you find the least common denominator?
Flip and multiply.
Or no, no.
In other words, turn the division problem into a multiplication problem.
Oh yeah, I forgot about that.
We don't even know how to divide. All division problems of this type are done by turning them into multiplication problems. And now start canceling.
So you cancel x plus 2. That's all you can cancel?
That x with that x.
Oh, okay.
Okay. So that gives us minus 11x plus 2 in the numerator. And in the denominator, we have 3x squared plus 3x plus 6. And I can't do anything more with that. In other words, I can't factor the denominator. I can't simplify anything. So, in other words, this looks hard, but it's not if you treat it as two separate problems. In other words, let's do this, and then separately, let's do this, and then we have a very reasonable problem, which turns into that. Okay.
Yeah, that makes way more sense than just finding a
I
entire
didn't like it when he told me about it. I didn't like that technique. For one thing, it's much harder to find four terms. You're looking at four terms trying to find a common denominator for those four terms. Oddly enough, I do use that technique if we had something like this. If I'm facing this kind of a problem, I really do like the technique of finding a single term that I can multiply both sides of the equation, which will eliminate all denominators in one step. And, in other words, I would multiply by 3 times x plus 2. And that would rid myself of all denominators in one step. And that's essentially what they're doing when they give you that other technique here. It's just, I'm not sure. It seems so much harder over here to do that than it does in a problem like this. I started thinking about that actually last night after I had this other student, because he told me they taught him to do this by finding a common denominator rather than treating that as a numerator and that as a denominator and simplifying each. Simply by way of understanding it, I think this technique is a notch easier.
Yeah.
So what are we going to do here?
Don't we just have to fix the denominator?
Yes, so let's start there.
And then you just multiply that by x, just 2. If you multiply x plus 3 by 2, we'll get.
Okay, so that produces what?
6 over 2x plus 6.
Yeah, let's leave it like that for the moment. And the reason is that I can see this numerator, that's going to have an x plus 3 in it by the time I take out a 4. So now I'm going to take this numerator. I'll go ahead and factor it. Why not? And I multiply it by the reciprocal of that.
All right.
That 4 cancels with those. That cancels with that. Oh, there's one more here, isn't there? Oh, no.
No.
Oh, that's that's the one I was just describing. There's going to be an equal sign there, and there's something on the other side of it. Let's look at 13. Tell me what the rest of 13 is.
So you have the first part, and then it's 4 over x minus 1.
This term is x minus 1, or is this plus 1?
Yeah, it's minus. And then equals 3.
That's it?
Yeah.
This piece of cake. I don't know, what's this one doing on there even? In other words, I can multiply everything by x minus 1, and I have 9 equals 3 times x minus 1, 12 equals 3x, x equals 4.
All right. I'm actually surprised that was on here.
Yeah, it doesn't look like it belongs, not looking at all these others. Let me just see. Number 8, you need to look at or not?
We can.
Yeah, it's a little different. Let's just make sure you can do these. I think you can. You seem to understand most of these. Are your grades coming up?
Yeah, it's up from where I started with you. It's up 20%.
Well, good. Good. So what's our first step? What are we going to do here?
You have to find a common denominator.
You want to try to find a least common denominator.
A least common
and they are different. In other words, you can always get a common denominator by merely multiplying all the denominators together. So I know that 2x cubed is a common denominator. But is it the least common denominator?
No. 2x squared is.
Yeah. How do you get that? How do you find least common denominators?
I don't. You just have to find.
Yeah, let's look at this problem here. How do I find the least common denominator with those three denominators? Notice that if I multiply them all together, it's 96. And that is a common denominator, but it's not the least common denominator. The way I do it, I don't know if there's an official technique, but I take my biggest denominator, and first of all, I find out if everything is divisible into that. No, it is not. So I increase it by 8. Is this divisible by 3 and 4? No, it is not. I increase it by another 8. Is that divisible by 3 and 4? Yes, I have found my least common denominator. That's the way I do it. Now, this problem, first of all, I would look at the biggest denominator. Is that divisible by everything? Well, no, it isn't, but it's almost. In other words, if I multiply this by 2, it would be. And I'm done. But, like I said, even if you don't use a least common denominator, you still get the answer right. It would just be a little harder. Yeah, you would end up with an x term in the numerator that ended up canceling out eventually. But the least common here is 2x squared. Goes here.
Just x squared.
Yeah, and then every time you do this kind of a step, make sure that you're looking at the same thing as you started with. Always do that check, and you won't make any mistakes that way. And it's pretty easy to see that if I started with this, well, if I cross that with that, I got 1/2. So it's an easy check to make. What goes here?
Which be 4x.
Yep. Is that the same?
Yeah.
Okay. And what goes here?
6.
Okay. And that does not look like it factors nicely. It does not, because we would need factors of 6 that subtract to 4. They don't exist. Do they? No.
No.
Now, let's say that I didn't see that 2x squared was the least common, and I just multiplied them all together. So 2x cubed is going to be what I would get. But then this is x cubed, this is x squared, this is 6x. I end up being able to factor an x out of the top, and it'll cancel with that one of those x cubed. You see what I'm saying?
Yeah.
You'll still end up with the same answer. So if you have a really hard problem and you don't know how to find the least common denominator, go with a common denominator and then simplify, and you'll get the right answer. Unless it's the kind of problem where I actually saw an interesting ACT problem the other day that it gave you a series of numbers and said, what is the least common multiple? Well, I didn't know how to find least common multiple. And after thinking about it for a really long time, I realized it's the same exact rules for finding least common denominator. You start with the big one and you start increasing it. Is that divisible by everything? No. And you just increase it by 34 every time until you find, by increasing this biggest number by 34, you assure that it's always going to be divisible by 34. So you keep doing this process until you find it divisible by both 8 and 11. And that's the way to find a least common multiple. Same exact way.
Yeah.
What else? Is there anything else you'd like to go over, Mitch?
Can you just, like, I don't think so, because that's the only thing I was having trouble with.
Was the complex
with the complex. Yeah, because the way they were teaching us was, like, extremely confusing.
Well, here's one of the keys. Yeah, they can do that for sure. Here's one of the keys. If you have something like this, I can immediately invert and multiply because my denominator is a single term. Even if that denominator is x plus or x over y plus z, I can invert and multiply. Here is when you cannot invert and multiply, is when you have a addition or subtraction taking place. If I have x over 2 minus y over 3, I cannot invert and multiply now. I have to produce a single rational quotient in the denominator. In other words, for me to do this division, I've got to operate on the denominator and turn it into now that is something I can invert and multiply. And that's the key on all of these complex ones, is you can't do this division until you add this variable to this variable.
All right.
Have any other questions on this sheet that you want to ask about or anything?
Can we do a division that's, like, it's like x squared minus 21 over x squared minus 2x minus 35. And then divided by x squared minus 7. Or, no, x squared, and then over x minus 7. Sorry, I messed up.
Like that?
Oh, and it's 21x, negative 21x. Up
Instead
there,
of x?
up at,
Oh, like that?
x, yeah.
Okay. Well, this one I can then flip and multiply. Right? In other words, there's subtraction going on here, but this is a single rational function. So I don't have to do anything previously to flipping and multiplying this. So let's do that. Flip it, multiply. Now, you'll notice this factors into an x minus 7 times x plus 5, right?
Yeah.
So x minus 7 times x plus 5, I can cancel that with that, and I can cancel one of these x's with one of those x's. See that?
Yeah.
So I've got x minus 21 all over x times x plus 5 is my final answer there. Now, let me point out one thing. I may have pointed this out numerous times. What is this equal to?
Is that -1?
Yeah. It's the only case I know of where you can cancel stuff out without them being the same, as long as you turn that into a -1. And you will see this on some of the harder problems. I would be surprised if you don't see a problem like this on the quiz. In other words, you end up with an x plus 2 times an x minus 1, all multiplied, and you got an x plus 7 down here. We're all multiplying it by x plus 7 over there, and down here we have a 1 minus x. Okay? So you might end up with a problem that looks like this. And of course you could cancel that with that, and you might stop at that point. But you shouldn't, because you can cancel that with that as long as you put a negative sign like that. So the answer to this would be negative x plus 2, or negative x minus 2. So look for that whenever you are canceling. In other words, when you've got everything broken down into linear terms and you start looking for what to cancel, realize that there is one situation where you can cancel it without them being identical. And that is that a minus b is always equal to the negative of b minus a. Notice that those two expressions are the same. If I distribute the negative sign over here, I get a minus b.
Yeah.
All right. Well, I'd be happy to answer any more questions you have, or we can be done. It's kind of up to you.
Yeah. I don't have any more.
Okay.
And but I have finals on
Couple weeks.
I'm staying.
Probably like everybody else, right before you go on Christmas break, right? When is Christmas break? It'd be good for you to know.
So it's
Probably the 22nd. Your last day of school has to be the 19th?
Our last day of school is the 18th because
Okay.
we have finals week that week and we have makeup days.
Okay.
But is there any possible way that I can move my tutor, or that I can just not have a tutor on the week of next week? I'm fine.
Okay. So you're good with these 3 times? 6 o'clock on Monday,
Yeah.
4 o'clock on Wednesday, 4 o'clock on Saturday. Okay. And let's look at this last week. You don't need this Saturday session probably.
Yeah, and I have my final on Wednesday, so I don't think I'll
Okay.
need
So let's move this Wednesday. Should we move it to Tuesday?
Yeah.
Tuesday at
if we
4?
can.
I can do that.
Yeah.
And this Saturday, just straight cancel it, or you want to?
Yeah.
You need an extra half hour that week because of final.
I won't need it after the.
No, I know you won't need it on Saturday. If you want to get in an extra half hour here, if you feel like you need it, you can let me know, and if I got a spot, you can have it. I will warn you that I am notoriously busy that week. So even though there's a lot of openings right now, by that week there won't be hardly any.
Yeah, could I actually make the Monday one instead of the 6th, move it to 4, and then just do an hour?
Yes, let's do that. And that's good. I'm glad you brought that up, because that will not be available probably.
and then I'll actually have my stuff ready for that
Great.
week.
So we'll do an
We'll
do
have
an
my
hour and a
final
half that
review.
week, and it'll be before your final. So
Yeah.
that'll work good.
All right.
All right. Sounds good, Mitch.
All right.
I will talk to you Monday.
Yep.
Okay. Have a good weekend. Bye-bye.